Hello, everybody. Thank you for joining us today for this session on an introduction to NAVconfig. My name's Jamie. I'm part of the automotive team here at OxTS, and I'm joined by Rihanna, who's part of our support team, who will be giving you this presentation. Got about just a minute to go before the start time, so we'll kind of get going in about a minute or so. But just wanted to say hello, and we'll get started soon. Okay, so by my clock just switched over to the start time, so we'll get going, see if there's any more people to join. But just whilst we wait for that, just to give you a little bit of an introduction, as you've joined today, you've been placed on mute, and the reason for that is just because this is being recorded, and you're going to receive this recording via email within about 24 hours of the session finishing. So there'll be a link in that email where you can watch this again anytime that you like, and as many times as you like as well. So that will be coming to you by email. If you do have any questions during this session though, there's a user panel it's usually on the right hand side of your screen. There's a little orange arrow. If you open that and you type in any questions you have into the question and chat box, they come through to us, and we'll answer those at the end. But if you want to type them in as they pop up, then that's fine. We'll answer as many as we can. I think we're scheduled to have about a 30-minute presentation, which means we'll have about 15 minutes for any questions. But with that, Rihanna, I will hand over to you to get started.
Okay, brilliant. Thank you, Jamie. So hello, everybody, and thank you for joining us. Welcome to this webinar on NAVconfig. So I just need to get my, hold on a moment. There we go. So to reiterate what you've been said, that we recorded, the presentation should last roughly about 30 minutes, and that's going to be including a little bit of an actual software demonstration as well. And if you've got any questions that you want to ask, you can ask those anytime in the questions box, but I will try and get to those at the end and answer those for you. So first of all, I'm planning to briefly go through some slides to give you the basics about NAVconfig. Then I'm going to open up the software itself and go through a configuration step by step. So if you have NAVconfig installed on your computer yourself, feel free to follow along and create your own config. I'm going to have an example set up in the slides, so when we get to that point, you should be able to see that and follow along. So, to introduce you, what is NAVconfig actually for? Well, as the name suggests, it's for configuring units, but there are several different aspects to this. So you can create a configuration, you can make a new one from scratch, but you're also able to edit any configs that you've made before from the .cfg file or from an RD file that's been logged on your unit. And you can also use it to improve a config after warming the unit up. Another thing that you can do in NAVconfig is upload feature codes. So there are certain features and functions on the units that are feature code locked. They're basically, you have to pay in order to get those. So if you do that, we send you a feature code and you can upload those to the unit through NAVconfig in order to get those features working for you. And you can also check the system info. So you can check what feature codes are already enabled on your unit, and you can look at the hardware config, so to see various details about what hardware is in the unit and what firmware version you are running. So when you get into NAVconfig, this is basically the first screen that you're going to see. So you've got these three options here: new configuration, modify configuration, and improve configuration. So depending on what you're actually trying to do, you would select the relevant option from there. Next screen you come to is this one. This is the read configuration screen, or if you've selected new configuration, it will be the start configuration screen. So this particular screenshot is from if you've selected modify configuration. And you can see on here there are several options for where you might modify a configuration from. So this includes any configurations that you've got stored in a folder on your computer, any settings that might be applied within an RD file that you've taken from your unit, or if you are actually connected to a device, you can read the settings in directly from the device. But as I've said, this page looks like depends on the option you select on the first screen. So the first main section that you come to in terms of the actual configuration itself is the hardware setup. So this covers the orientation of the IMU, so how it's mounted in the vehicle, the antenna placement in relation to the unit, and any no-slip settings, so the lateral and vertical no-slip. And you can also set up GNSS differential corrections in this section, and the LiDAR scanner if you are using one of those. So we come to the interfaces section. So we've got various different potential outputs that the unit will output. So this includes Ethernet and CAN, as well as serial. We've got some other potential outputs as well. And in this interfaces section, we've also got the Wi-Fi tab, which applies to our V3 models, because this has onboard Wi-Fi that can be used to interface with the unit and the PCs. So next we have the environment tab. So this is where you would set up anything to do with your initialization. You can also set up what your GNSS environment is like, so whether you are in open skies or in somewhere that has obstructions. You can set up the vibration levels. Ordinarily, you would probably just have this set on normal, although there are some occasions where you might want to set that to high vibration. It really depends on sort of what kind of tests you're doing and whether or not you're likely to have any relative motion between the unit and the antennas. This is also where you can set up the heading lock, so that helps to reduce drift when the vehicle is stationary. And from this section, you can also configure surface tilt and local coordinates. So I will talk about those in a bit more detail during the demonstration. Then this next section is the advanced tools section. So from here, you can set up the GNSS control options, so whether or not the unit is using the receiver calculations or our GX algorithm. And you can also set it to mixed mode, where it will select between the two previous options to optimize the output. You can also set up the wheel speed. If you've got a wheel speed sensor in there, that can help to reduce drift on output. You can set displaced output. This is also where you would configure your different accuracy levels. So we very often recommend keeping those set to the default values, but I will talk about that a little more later on. And you can also, through the advanced commands section in this, the advanced commands tab in this section, you can also add any additional commands that aren't available in the GUI itself. So next, we've got the right configuration section. So from here, you would basically be able to save the configuration that you've created. And you can save that to file by clicking on the big save icon in the corner. And that will allow you to just save that locally on your PC. You can also commit the configuration to the unit through here. So you basically select that from the drop-down menu and click commit. You've got these two options, so you can either just save the changes and reset the unit at the same time, or just save the changes. But in the latter case, it will only actually apply those changes once the unit has been power cycled. So that is the basics of NAVconfig. So before you actually get started on trying to configure your unit, you would generally set it up in the vehicle beforehand, because there are various different things that need to be measured before those can be input into the configuration. So first of all, you can mount the RT. So we have the option of using the RT strut, which is just a strut that you can mount in your vehicle. Or if you have your own sort of mounting solution, you can use that. But you want to have the RT rigidly mounted in the vehicle. Then you can position and mount the antennas on the roof. So we recommend that that's at least 20 centimeters away from the roof edge. And if you are using two antennas, they should be with the same orientation, as you can see in that little diagram in the corner. We also do recommend that if you are using a dual antenna setup, you have at least 1 meter of separation between the two. So once you've mounted the antennas, you would then plug in the main user cable for the device and connect the antenna cables between the antennas and the unit. And then once you have supplied power to the device, then connected to it via an Ethernet cable, you should be able to actually see the device in any of our NavSuite programs. So it should be it should pop up in that little drop-down menu that I indicated before. So we've got here an example configuration, and so this is where we're going to start actually creating a config ourselves. So this is basically just an example of the setup. So you can see in the center there you've got a unit mounted on a strut, and we've got all the various different distances between where the unit is and where the antennas are, as well as distances to the no-slip points I will talk about as we go through. So if you want to try and follow along creating a config yourself in NAVconfig based off this setup, now would be the time to do that. So I'm just going to open up NAVconfig. Bear with me. Right. So we've come to this first screen, 3 options. So for this demonstration, once it's fully loaded, I'm going to select new configuration since we're creating one from scratch. Now, one of the differences between the new configuration and the modify configuration option is that the new configuration option will make you go through step by step. When you're modifying a configuration, you can jump around between the different tabs like to your heart's content. But when you are creating a new one, the software forces you through to put in all the necessary details in order. So as you can see on this screen, the start configuration screen, it looks a little bit different from how it did in the slides, because in this case I've selected new configuration rather than modify. So we have these two options at the top here. So we have the option to either connect to a device if there are any on the network, or if you don't have one connected, you can just create a configuration based on settings that you input, and then you would have to later on commit that to the device instead of doing it right from, well, you would be committing it at the end anyway, but it won't read in any features that are already there. So in this case, because I will select no configuration to device, I will first of all have to select what product type I'm going to configure. So show you certain tabs aren't available for all of our units. I am going to select an RT3000V3 because this has certain features that I can show you how to configure that aren't available on the other units, or not all of them anyway. So then we would select from the type of vehicle that the device is being installed in. So in this case, we've got a land vehicle, and this just changes some of the options that are available because, for instance, if you selected an aerial vehicle, it wouldn't come up with the options for the lateral and vertical no slip, since those are things that aren't going to be assumed in that sort of vehicle. First, we come to the IMU orientation in the hardware setup. So you're given these two drop-down menus to determine which way the y-axis and z-axis are pointing in relation to the vehicle. So the diagram here, you can see that the y-axis is going to be pointing to the right of the vehicle. Hopefully you can translate from the one that's in that diagram there. So say the y-axis is pointing to the right. You can also see that the z-axis here is going to be pointing towards the rear of the vehicle. So backwards. So in general, we do recommend that you mount the unit orthogonally to the vehicle, but obviously there are going to be times when that's not possible, and since it's not always the case, we do actually have the option to specify exact angles. So if you want, you can input values here. And one thing you notice when I selected that, we've got this little target logo. So anytime you see that throughout NAVconfig, it basically means that it's something that can be improved automatically when you warm up the device. I'm going to untick that for now. And so you notice that all of these tabs are currently grayed out. In order to progress, you have to select next. I will just demonstrate what happens when you press next without having input anything. So it gives you a bit of a warning. So if we look at the that we've got here, we're going to be taking this antenna that's at the front of the vehicle as the primary antenna, and then take the rear one as a secondary antenna. So first of all, we're asked to put images of the primary antenna in relation to the unit. So we can see from the diagram that it is a head distance here of 1.2 meters. So, and then next, we've got the option of is it to the left or to the right? Well, from here, we've got this assumption listed here that the RT and the antennas are installed on the center line of the vehicle. So in reality, it doesn't actually matter because it's going to be 0 either way. And finally, whether or not it is above or below the unit. So in this case, it is above. And we can see from that we've got a distance from the ground given here rather than directly from the unit itself. So in this case, you've got a distance from the ground of 1.45 meters for the antennas, and then for the unit, it's a distance of 0.8 meters. We'll do a little bit of maths there, and that comes out at 0.65. And again, you've got this little target icon here, so those are measurements that will be improved by a warm-up. The secondary antenna, so in this case, the antenna is level, we can leave that one ticked. As we can see from the diagram, the secondary antenna is behind the primary antenna by 1.5 meters. So the thing antenna is that you are measuring it in relation to the primary antenna rather than in relation to the unit, like you were with the primary antenna itself. So if we pop that in there, and again, this is something you can specify the exact angle. Next, we set up the lateral no-slip constraint. So in general, this would be the distance to the rear axle, mostly because in most vehicles, that will be the non-steered axle. In general, if you are using a vehicle with a different setup, you would switch that as needed. So we've got non-steered at the rear, and we can see that that is 0.8 meters behind the unit. Once again, we are moving to the center point of the non-steered axle, and since the unit is mounted on the center line, that is going to be 0. So how far below is the ground from the device? This measurement here, so that is 0.8 meters. So we pop that in. Next, we've got the vertical no-slip constraint. So in this case, you are measuring to the center point of the steered axle, which in general will be your front axle. So as you can see here, we've got a distance between the front and rear axles of 2.8 meters. So if we subtract the distance between the unit and the rear axle, we can get the distance between the unit and the front axle. So that is going to, in this case, it's ahead. Once again, because it's on the center line, doesn't matter if we put left or right, because it's 0 anyway. So next, we've got the GNSS differential corrections options. So the important thing to remember here is that you have your correction format set to the same format as your base station or NTRIP provider, etc., is actually providing to you. So we've got various different options in here. We've got it on RTC-MV3 by default. So you can enable NTRIP through this section, and in some of our units, I think it's largely the V3s, they have an internal NTRIP client. This is feature code locked, but it can be added. So in this case, because you can see that this lock is unlocked, in this case, it means it is enabled on this type of unit. Anywhere we've got padlock, it's not enabled by default. Or in the case where you are actually connected to a unit, it signifies that it's unlocked on that specific unit. Depends on how you've got things set up. So you can select this from here, and then you just have to input these particular settings and select your mount point from the drop-down menu, and then any credentials that you need to put in order to access your NTRIP provider, you would pop those in here. I'm going to untick these for now. So again, you want to make sure that your serial port settings for the radio modem, if you're using one, match in here. And you've got your base station data here. We've got various different options, although by default it's WGS84. And you can also set up SBAS over here. And if you've got a TerraStar subscription, you can set that here too. Next tab is for setting up a LiDAR scanner. So if you happen to be using one of these, you can set that up through here. but in a basic setup, you're not going to be using that. So move on. So this next section is the interfaces section. This is where you can set up the details of the various outputs. So we want to leave this checked because otherwise it will make it, it will mean that the software is unable to read the Ethernet data from the unit. Different types of output packets. So our usual one is NCOM, but we do have this MCOM option, which is for marine applications because it includes a heave measurement. So from here, you can set up your data rate up to the maximum that is available on your unit. So generally, most of our units have a maximum of 100 Hertz. There are some units with a maximum of 250 Hertz. So depending on what sort you've got, you'll have different options available here. You can also set up an asynchronous Ethernet pack output, so based on triggers rather than just on the timings here, and those can be set up through here. And if you're using a driving robot, this is where you would set that up as well. Next, we've got the Wi-Fi options. You can generally see most of these settings here, but as I don't have a device connected, I can't actually go through and configure these. But you would basically have a selection of Wi-Fi networks that are in range popping up in this box over here, and you can click and goes onto a prioritized connection list here. Next, we've got CAN output. So you can set this up. We've got different options. You can use CAN 2.0 or CAN FD, and you would set your bit rate over here. And one thing to remember is that you want to make sure that your current CAN messages per second does not exceed the suggested maximum, which will change based on what bit rate you have set to there. So in this case, because that is higher, it gives you a warning that that would overload the CAN bus. So I will set that back to there. We've got various navigation messages that you can enable and status messages as well. And then you can export that as a DBC to be used by whatever CAN logger you're using. I will disable that for the moment. Next, we've got CAN acquisition. This one is feature code controlled, but it essentially means that you can use the unit as a CAN logger itself. So you are acquiring CAN on the unit up to a maximum of 12 different messages. So you would have to import a DBC file into this section, and that will populate this list in the center here, and then you can enable whichever messages you want to actually acquire through that. Then we've got the serial output, so we've got different packet types available here. You can output your NCOM and MCOM through the serial port, but we've got various different options, as you can see in the drop-down menu there, and this is where you would set your baud rate. Next, we've got the analog output options. So if you're using your unit with an RT-ANA, you can enable your analog outputs here and set your min and max values and so forth in this section here. Next is the PPS and triggers tab. So this will enable you to configure your digital inputs and outputs. So whether or not the active edge is the falling edge or rising edge, and set your trigger types and the ppm of those inputs and outputs. We've got the environment section. So this is where you can enable static initialization if you have, or if you are using a dual antenna setup. Otherwise, you can set the dynamic initialization speed, and this is basically a speed at which once you drive at that speed, the unit will initialize. So we recommend, so we've got it by default on 5 meters per second, which is generally sufficient for maneuvering a vehicle to a point where you can drive straight ahead in a straight line, because in order to initialize the unit properly, it does need to initialize in a straight line. So as long as you can maneuver at a speed below this value that you put in here, you should be all right there. You can also set whether your vehicle is starting level, so that's within 5 degrees. And in this section, we've also got the GNSS environment options. So we've got 3 options here: open skies, some obstructions, or frequent obstructions. So the latter is going to be the sort of thing you use if you're driving in sort of the center of a city, for example. And this basically just changes the weighting given to the GNSS measurements compared with the IMU measurements that are being taken by the unit. You can also set your vibration levels here. So we've got normal, high, and very high. For the vast majority of cases, you will have this just set on normal. Then we've got this measurement drift reduction option. So this is the heading lock. And you can have that by default, it's set on normal, but you can disable it. But we've got these other options to have that a tighter heading lock, so it will drift less than the value associated with it while the vehicle is stationary. We've also got garage mode, so this is basically something that you can select to stabilize the outputs when a GNSS signal is unavailable. For example, if you drive into a garage, because obviously GNSS signal operates on line of sight. So if you've got something blocking that, it can cause a large amount of drift when the signal is unavailable. Then we've got these other 2 options in here: surface tilt, which is something that you would use if you are testing in an area where the ground isn't actually level and it has a specific angle to it. So you can set what the uphill heading is and what the surface gradient is. This is something that can also be configured through the quick config option of nav display, and in that case, it allows you to actually set that up without having to know the necessary values prior to configuration. Similarly, with the local coordinates, this allows you to set up a local coordinate grid and get your outputs in X and Y on that grid rather than just in sort of an absolute coordinate system. So you can either read in local coordinate settings from a device that's already got them on, or you can input your origin, lat, long, and altitude, and your x-axis angle. Again, these are things that can be configured through the quick config utility in nav display. So if you don't actually know those values right out the gate, you can set those up and just get the unit to set the origin at like its current location, for example. So that is how you do that. And then we go to the advanced tools. So I've already given a brief explanation of the GNSS control options, so I will move on from there. But we've got this global coordinate system option. Again, the datum can be set to a few different things, but by default, that's on WGS84. It's good to keep that sort of consistent throughout your configuration and consistent with whatever corrections you're using, because sometimes those will be given with a different datum, and if you have the unit configured with a different datum from how your corrections are configured, you can end up with some offsets that you don't want. So next we've got the wheel speed input. So this is set up in basically the same way as you did all your other hardware setup. So you've got your directions and your distances. You're basically just putting in the distances and directions between the unit and the measurement point of your wheel speed sensor. And then you get the meter that you want there as well. And again, this is one that can be improved by the warm-up. Next, we've got the acceleration filters option. So this can be quite useful if you are displacing your output, because when you displace the output in a given axis, you are likely to end up with some additional noise on the acceleration output on that axis. So this allows you to set up a filter that can filter that out. We've got an angular acceleration filter and a linear one, options for your filter types, and you can set your various different options here. Next, we've got output smoothing. This is pretty much going to be irrelevant to you unless you are using a driving robot. It's basically intended to prevent any large jumps in output from sort of causing major jumps in the motion of a driving robot, so it'll smooth that output there. Next, we've got GNSS recovery. So this basically controls whether or not the unit is going to ignore unexpected GNSS measurements. So you can tell it never to use the unexpected measurements, or give it a certain number after which it will start using them. So that's both positionality there. Then we've got the display output option. So again, this is done in the same way as your other hardware setup. So you've got your direction options and your distance options. You can put those all in there. I haven't yet mentioned you can change what units you're using. So these options are given in metric. There is an option that I'll tell you about in just a moment where you can set those to imperial measurements as well. Yeah, so that's how you set up your displaced output option. And actually, it's worth mentioning with the output, in case you aren't already aware, this basically causes the unit to output all its measurements as though it's mounted at the point that you specify, rather than at its actual location. Obviously, because the dynamics of a vehicle are going to be different depending on where in the vehicle the RT is actually placed, you will end up with some slight differences, hence why you have sort of noise on the accelerations, for instance. But it's worth saying. So next, you've got your slip points. You can set up to 8 different slip points, and it will give you an output of the track, slip, and curvature for those measurement points. And if you've got those set up, again, you are setting them up in the same way. You've got your direction and your X, Y, and Z dimensions, and your distances that you would set up there. Next, so this is a section that enables you to put in any advanced commands that you may have been given by the support team or found in our Help Center articles. This is basically any specific commands that aren't available in the GUI itself that will enable certain advanced features. Generally, you'd leave this blank for any basic setups. And then finally, you've got this section on the accuracies. These are all the default 5 degrees for any angles and 0.1 meters for any distances. We've got an exception to that here, is 0.05 meters for the distance, the anti-separation distance. But generally, we recommend, at least to start with, that you keep those set to the defaults, just because, especially for the distances, it means that if you've over constrained it instead of using the defaults, it might result in the unit having trouble finding a position solution, because it might be trying to converge on a solution in the wrong place. So then you finally come to the right configuration section. So again, you can save this to file here. So if you just click on the big save logo up the top, you can input a configuration name. So there will be a default folder that this will save into, but you can change that through the settings. I will talk you through that in a moment. But you can also click on this export button here. There's places that you can save it. It will just give you your usual Explorer options there. So you would normally have a device connected on your network, and it would show up in this drop-down menu here. Since I don't actually have anything connected, nothing's showing up there. But once you've selected the unit you want to commit the configuration to, you press the commit button, and it will show the progress under here. So that is basically how the software works. We've got a couple of other options I can show you. We've got this
Sorry, Rihanna,
in this case,
can
because
you
the
hear
device is
me?
offline, just having the default options for T3000v3, and we've got the information.
Sorry, Rihanna,
I am
can you
unable to
hear
hear you
me?
now.
Can you hear me?
I'm not sure if there's a problem. I can now.
Yeah. You're just
I
sorry.
can.
You broke up slightly around the feature codes and system information. Can you just repeat that repeat from what you just said around feature codes, just because it was a bit broken up just then?
Okay, sure. So I was basically saying that because I don't actually have a unit on the network, it is just showing the default feature codes, the type of unit that I'm trying to configure here. So that's an RT3000v3. But if you are connected to the actual feature codes that are enabled, there's also this system information tab. Again, unit, it's not going to show it, but it does give you some information about the hardware and what firmware you are running on that. There's also this option to change various settings. So this is also where, as I previously mentioned, you can input your folder for saving configurations, and you can select language options here and your measurement unit options here. But other than that, that is pretty much it for the demo. So I will get to the
Okay, thank you very much.
Oh dear, it's gone right back to the beginning there. So once you've configured a unit, you want to warm up the unit. So to do this, you need to initialize first by driving in a straight line through the initialization speed that you've configured. And then you perform a series of maneuvers. We recommend doing figures of 8, braking into turns and accelerating out, driving in a circle at a fixed speed and decreasing the radius of your turns as you go along, doing those in both clockwise and anti-clockwise direction, slaloms with short, sharp turns, and applying hard acceleration and hard braking in a straight line. So basically, we do recommend that you have the speed and intensity of your warm-up matching the speed and intensity of any tests that you're doing, so that it essentially calibrates itself to what it should be. Next, you've got this Get Improved Settings option. So this was the third option on your first screen of NAVconfig. So once you've warmed up the device, you can improve the configuration and it will apply any improved settings. And so you have things like offset as well. And once you've applied these settings, you would need to reinitialize your unit and complete a quick warm-up. In this case, it will get down to specification quicker than your initial warm-up, just because it will have already applied certain settings to reduce the errors. Right, so that is it for my presentation. Thank you very much for listening, and I will hand back over to Jamie for any questions that we may have received.
Yeah, thanks very much, Rihanna. As we said at the beginning, if you do have any questions, please do drop them into the questions box on the user panel. If you open it up using the orange arrow, you just type them in there and we can answer them. If you don't have any questions now, then no problem at all. Obviously, if you do have any that come up after the webinar, after you've watched the recording, which will be with you in the next day or so, then you can always reach out to us. The best way to do that will be, as Rihanna's got there, the contact the OxTS support team at support.oxts.com. You can raise a ticket there, and we can give you kind of one-to-one support to help resolve any questions that you have. We haven't had any questions at the moment, Rihanna, but so what I suggest, as we're just coming up to the hour mark for time anyway, if you do have any questions, please put them in just while we wait to see if there are any. We also have some other webinars occurring over the next couple of weeks. So tomorrow at the same time, we have best practice for accurate measurements in RT range. And then next week, some further ones in terms of introduction to NavSolve and NavGraph, and introduction to NavDisplay as well. So if you want to sign up for those, they're all available there on the, as the link suggests, oxts.com/resource hub. You can find them all there and register for them as you wish. Doesn't look like we've got any questions at this stage, Rihanna. So I think all that remains to be said is, thanks very much for a great presentation, and thank you for everyone for joining. And we hope to see you on one of those future ones soon.
Right, thank you very much, everybody, and have a good afternoon. Goodbye.
Thank you.